Hello viewers, welcome to this video. I'm Venkat and this is Just Me, an open source channel. Right, in this video I'm going to talk about LXD containers, what the LXD and LXC containers are, how to use them. I'll also show you a quick demo of how you can get started with using the LXD containers. As usual, I've got my notes here to explain you things a little better. Okay, so we've got virtual machines and the LXC containers and the application containers, basically Docker, RKT, and so on. Okay, so how this LXC machine containers differs from a virtual machine or application containers. So basically, when you use virtual machines, you've got your bare metal and you've got an operating system running on top of it. It could be Linux, Windows, or Mac OS, and you install a hypervisor on your operating system. A typical example would be VirtualBox, and you create virtual machines on top of it. So that's the hypervisor bit, and each of the guest operating system is a complete operating system. All the hardwares attached to these guest virtual machines are all virtualized hardware. So the hypervisor is responsible for giving the guest OS the hardware from your bare metal in a virtualized fashion. So that's virtual machines, and we all are familiar with the Docker containers or any container platform. There is RKT and Docker. So similar to virtual machines, you've got your bare metal, you've got your operating system installed, Linux or Windows or Mac OS, and you install a container runtime. It could be Docker, RKT, or anything. And then you create these container images. So these are not virtual machines. So you're not running a complete virtual machine. It's just an application container. You grab the libraries, the dependencies that your application needs, package them as a container, and you start containers. So containers are very lightweight compared to virtual machines. You're not running an entire operating system, so it's just a set of files basically your application requires. You package them as a container, and the container runtime is responsible for managing multiple containers. So that's lightweight. You can have multiple containers. They're all very lightweight. So where does the machine containers sit? So it sits between the virtual machines and the application containers. It takes the best of both the worlds. So how is it compared to virtual machines? So the LXD, LXC containers that you create are a complete operating system, not just an application container like Docker. So it's a complete operating system similar to virtual machines. And how is it compared to Docker? It's very lightweight. It doesn't need a hypervisor or a container runtime. It sits on top of the Linux OS. It uses the LXC libraries, and LXD is the REST API. Your command line tool interacts with the LXD API to access the LXC libraries, and you create your guest operating systems. So it's a complete operating system, and all the hardware, whether it's a CPU, memory, USB ports, and so on, everything is available to these guest OS. You can start the container in a matter of seconds, a complete operating system. It's a very quick one. I've been recently using, I was using virtual machines, and I use Vagrant to provision virtual machines. But recently I started using, because of the simplicity and lightweight nature, I started using the LXC machine containers. Okay. So you can deploy a container, I mean a machine container in a particular host machine, or you could have a cluster of host machines running LXD on each of them, and basically that's a cluster. For this video, I'm not going to go into the cluster mode. I'm just going to use a single virtual machine to do that. Okay, the next thing is comparing to virtual machines. So, for example, if you've got VirtualBox or VMware or any hypervisor installed, say for example your host memory has 16 gig of memory, and you're creating a couple of virtual machines. So one is each of these virtual machines, you specify 4 gig. So basically, you're taking 8 gig out of the 16 gig of your host memory. So your host machine is left with just 8 gig. So when you allocate 4 gig to a virtual machine, you're allocating the entire 4 gig to the machine. That's it. So it's not available to your host machine. Whereas in the LXC and LXT containers, um, you don't specify anything, although you can limit how much memory a machine container can take. Um, if you don't specify anything, the entire host memory is available for every single machine containers that you create. So when your host memory is 16 gig, when inside your container, if you look at your memory, and the whole 16 gig is available for each of these containers. But I'll come to show you in the demo how you can limit the amount of memory that each containers can take. Limits.memory, limits.cpu, you can set limits. Okay, so what we'll be doing in this quick demo, I'll show you some commonly used commands, how to start, stop containers, how to pull images, do a snapshot, apply certain profiles, and so on. And also, there is a possibility to do a nested containers. Say you create a machine, you create an LXT machine, and inside that LXT machine, you create another LXT environment, another LXT. So basically, you can nest multiple levels. Okay, so let's get into the business. So I've got an Ubuntu virtual machine. So my host machine is Arch Linux, and I've got a virtual machine because most people are using Ubuntu. I thought it would be useful to show this demo on an Ubuntu machine. I've also got an LXC environment set up on my host machine, Arch Linux. So if you're not aware, I'm also doing a series on Kubernetes. So I'm using the LXT containers for Kubernetes. That's from my host machine. But for this demo, I'm going to use the Ubuntu 1804 virtual machine. LSB release minus DIRC, which is 1804. And this virtual machine is run from VirtualBox. Okay, so that doesn't matter. Okay, how do you install LXT? In Ubuntu 1804, I'm not sure about 1604. I haven't checked actually, but in 1804, LXC and LXT are already installed. If you do which LXC and which LXT, you'll find LXC and LXT installed. So dp kg -l, you can check whether a package is installed. grep LXT. So I've got the LXT package installed. If not, the command to install is sudo apt-get install LXT. That's it. Okay. So once it's installed, there's a service, but it's not started. If you look at LXT service, so that's the service that needs to be running. And you can see it's enabled indirect. It's not running at the moment. So the first thing to do is to start the LXT service. Sudo systemctl enable. Now that's already enabled. Let's just start it. Start LXT. So sudo systemctl status LXT. It's running now. And the next thing we got to do is there's a group called LXD. And if you want to run LXC commands without prefixing sudo, you need to add your user account to the LXD group. So I'm using Vagrant, so my user account is Vagrant. So I'm going to add Vagrant to the LXD group. The command to add is sudo gpassword -a add user Vagrant to the LXD group. GetInt password getInt group LXD. So now Vagrant is a member of the LXD group. For the changes to take effect, you can either do new group LXD, or you can just log out and log back in. Vagrant SSH. Okay, groups. So I'm part of LXD group. So now what I can do is, once you start the service, the first thing to do is to initialize the LXD environment. So the command to do is LXD init. Would you like to use LXT clustering? As I told, you can set up an LXT cluster, but for this video, I'm just going to install it on one machine. So the default is no. Do you want to configure a new storage pool? So all the machine containers will use this storage pool for storing the file systems. Yes, definitely, because this is a plain installation, so it won't have any storage pool created. So let's create one. Name of the new storage pool, it can be any name. Let's leave it as default. Name of the storage backend to use. The default is Btrfs. It comes with lots of advantages. You can do a snapshot, you can do lots of volume management, but for simplicity's sake, I'm going to use the dir, which is directory on your host machine. Would you like to connect to MAS server, which is Metal as a Service server? No. Would you like to create a new local network bridge? Yes. So again, this is the same machine. If I do the IP address is 172.42.42.101. So that's the network interface, the active network interface of the host machine. And we need to create a network bridge so that all the machine containers that we are going to create will use that network bridge to communicate to the outside world. So let's create the network bridge. What should the network bridge be called? By default, it's LXTBR0. We can call it any name. Let's leave it to the default. IP address, what range do you want? Let's leave it to default. Automatically assign IP version 4, version 6. Would you like LXT to be available over the network? No, I just want to access it from this machine. I don't want to access it from other machines. Would you like stale cached images to be updated automatically? So when you first launch any of the machine containers, it's going to pull the machine image from a remote repository. So once you pull that, every time you start a machine, it's going to use the image that it has pulled to your local machine. This setting tells that to periodically check that whether the local image is an up-to-date image. If it's not, it will sync the image from the remote repository. So let's leave it to default yes. Would you like YAML init preseed to be printed out? Basically, all these options that we just entered, do you want to be printed out? Default is no. That's all the questions, so we're all good to go. And if you do LXC version 303, server version 303, okay, so it also gives you a command to start your container, do an LXC launch. So before that, I want to show you a few other things. To show the list of available commands, do an LXC help. LXC help, pipe that to less. So there are lots of handful of commands that you can use, and I'll show you some basic commands, most commonly used commands. If you want to know more about a particular command, you can use the help option. For example, for storage, if you want to look an example for storage, LXC help and the command. Okay, so you can create storage, delete, edit, get info, list, and so on. LXC storage list. So that's the default storage. The driver is directory. Remember, we did that during the LXT init command. And that's the directory where it's going to store all the machine images. Okay, so where is it going to pull the machine images from? LXC remote list. So there are a couple of few repositories that's been added. So images, so that's the one. And there are Ubuntu releases, Ubuntu containers. So there are 3 repositories added. So when you launch a new machine, it's going to pull from these repositories, and the local is just the local repository. Whenever you pull it from the other 3 servers, it's going to store it locally on this machine. Okay, so let's try and search for a container. Say, for example, if I want to start a CentOS machine, how would you start it? Or how would you find if there is a machine image available for CentOS? LXC image list. So that's the list on your local machine. I don't have any images on my local machine. Okay. LXC image list images colon. If you just do images colon, it's going to list all the images available on that particular repository. There are lots of images, Debian, Alpine, CentOS, and so on. And if you want to search for a specific one, you can start typing few letters of it. So if I just do cent, you can see CentOS 7, and there should be lots. If I pipe that to less, you can see CentOS 6, i386 version, CentOS 7, ARM64, and so on. Okay, if I want to search for Debian, and there is Debian here, Debian 10, 9, and so on. Okay, so that's how you search for the machine images. So how would you start it? So I want to start an image now. Okay, so in this host machine, if I do uname, the kernel is 4.15. So this kernel is for Ubuntu 18.04, and all the machine containers, whether it's CentOS, Debian, Alpine, or whatever machine container you're going to use, it's going to use the host kernel. It's not the OS specific kernel. It's whatever the host kernel is, it's going to use it. Okay, so let's try and start an Ubuntu 16.04 container. LXC launch is the command. Launch and the container name Ubuntu 16.04. So if you're using any of the Ubuntu, you don't have to prefix the remote repository path. If I show you LXC LXC remote list. So when you do Ubuntu colon 16.04, it's going to pull the image from this repository. So you don't have to prefix Ubuntu, but if it's anything else, you need to prefix images. Okay, so let's try and create an Ubuntu 16.04 image and a CentOS 7 image. LXC launch Ubuntu 16.04, and if you don't specify a name, it's going to give you a random name. So let's try and but before that, if you want to see what machines are available, what machines you've got, you can do LXC list. So at the moment we don't have any machines, we don't have any containers started. LXC launch Ubuntu 16.04. It's going to take, for the first time, it's going to take a little while, maybe a couple of minutes, depending on your internet speed. So it's pulling the file system to your local machine. So once that's done, that's the base image, and all the other containers you're going to start, it will start from the local image. So the next time you're going to start it, you're going to launch a new container. It will take less than 3 or 4 seconds to start it. Right. It has started the container. Now if I do LXC list, and there you go, the state is running and it has got its own IP address. And after we did the LXD init command, if I look at the network interfaces, you will see LXD BR0. So that's the network bridge for all the machine containers this host is going to create. So it has got the IP address 10.149.213.1, and all the machines will get the IP address from this bridge. So 10.149.213.165. So that's in the range of this IP address there. And for each machine container you create, you're gonna see a virtual Ethernet interface on your host machine. So that one is for this machine. I forgot to give the machine a name, so it defined a random name. Okay. Let's delete it. LXC delete and the container name horse. You'll see an error here. It won't be able to delete it while the container is running. If you want to delete it, you need to stop the container before deleting it. LXC stop sweet horse. Or if you want, you can pass ---- force command that will stop the container for you and delete it. So let's do the stop. LXC list. So the container is stopped, and if you want to start the container, LXC start. LXC list, LXC start, and the container name, Sweet Horse. LXC list. See how quick that is? LXC list. Okay, the container is running. Let's delete it. Let's delete it with the force option. LXC delete minus minus force Sweet Horse. Okay, that's deleted. LXC list, that's gone. LXC image list. So that's the local image that we downloaded. Ubuntu 16.04, and the total size that I downloaded is 158 meg. It's so lightweight. And now if I do LXC launch, if I launch a new Ubuntu 16.04 container, it's going to be very quick because we've got an image already in our local machine. LXC launch Ubuntu 16.04 and give it a name, My Ubuntu. Creating My Ubuntu, and then it will start it. Okay, the container has been created. LXC list. Okay, there you go. It has got a different IP address now. Okay, cool. LXC list. If you want to copy this machine container, you can do LXC copy My Ubuntu to my another Ubuntu. LXC list. So now we've got another machine which is stopped. You can start it with LXC start my another Ubuntu. Okay, that's started. LXC list. You can see both these VMs, both these not VMs, both these machine containers are running. They each got their own IP address. Right. LXC list. So that's copy. Let's delete it. LXC delete minus minus force my another. Okay, before deleting it, I just want to show you how you can reach one container from another container. Okay, let's keep that for a moment. And if you want to rename a container, or if you want to move a container, say if you've got an LXD cluster, obviously we don't have a cluster at the moment, but if you've got cluster, you can use LXD move command to move the container from one host to another host. And to do that, LXC move is the command, my Ubuntu, and give it another name. If it's on another host machine, you need to give the host name, colon, and the path. But I'm going to move it within this host, so I'm going to give it another name, my Ubuntu to my VM. Okay, renaming a container is not allowed while it's running. LXC stop my Ubuntu. And then we do the LXC move command. That's done. LXC list, and you can see my VM, it's been moved to my VM. LXC start my VM. Okay, that's started. LXC list. Go. So we've got two VMs. Okay, so we've got the machine containers. How would we log into the container, or how we can use the container? So if you have used the Ubuntu container, there is a default Ubuntu user account in these machine images. But if you want to log in as root, you can do LXC exec and the container name, my VM, and the command bash. Okay, so I'm inside the my VM container. If I do hostname is my VM, that's cool. LSB release. So that's Ubuntu 16.04, the machine that we started. It's a complete operating system, a very quick way to spin up a virtual machine. And if I do free minus M, so it's 2 gig. Basically, my host machine, I mean the virtual machine, has 2 gig, and the container can see the complete memory. So I've got one CPU and one CPU here. Okay, and if I do uname minus R 41545, which is the host kernel on my Ubuntu 18.04. Right, and you can ping the machine containers. You can ping between the machine containers using the DNS name. So when you create the LXT bridge, you can ping the other containers using .lxt naming convention. So our other container was, I need to log out and log back in. LXC list my another Ubuntu. So if I want to ping it, ping my another Ubuntu.lxt. Okay, so I'm getting ping response back from that container. And if I want to log into my another Ubuntu as user Ubuntu, what you can do is you can do sudo-ubuntu. Okay, hostname, I'm inside my Ubuntu virtual machine. LSB release there. Okay, 1604 ping my vm.lxt. I'm getting ping response. Okay, cool. So what else we can try? We did an image, we did launch, start, stop, we did delete, list, exec. So we've completed all these commands. So let's go to these set of commands. So config, info. If you want to look at the details of a machine container, you can do LXC info and the container name, my VM. Let me pipe that to less. So you can see remote. I mean, where it's running from, it will give you the path of the machine the container is running, when it was created, what architecture, and the current status of the machine it's running. Profiles, I'll come to profile in a minute. PID is 7629. If I search for PS3 minus P 7629. Okay, so that's the process isolation. Ethernet interface, the address of the Ethernet interface, how many process it's running, 28 process, CPU usage, memory usage, so it's only using about 50 meg of memory. Network, bytes, and some stats, so that's LXC info. And there is also machine configuration. If you want to look at the machine configuration, LXC config show my VM. So that's the complete configuration of the machine, right? And it's using the default profile. Okay, so I'll come to the profile in a minute. We've also done the copy and the move command. Okay, let's go to the profile. LXC profile list. So we've got only one profile and used by two containers. So as we've got two machine containers and we didn't have any profile, by default it uses the default profile. So what's in the default profile? LXC profile show default. So it hasn't got any configuration, it's just a description and a name, and the storage pool is default storage pool, which we created during our LXT init command, and the type is disk. What's the Ethernet interface and what's the network bridge? We are going to use LXT BR0. So that's the default profile. And if you want to create a new profile, you can copy the existing profile, LXC profile copy default to a profile called custom. And if I do LXC profile list, you can see the custom profile and it's used by 0 containers. And if you want to launch a container and use this profile, you have to use LXC launch container image name Ubuntu 1604 or CentOS 7 or anything, and give it a name my VM2 minus minus profile custom. So the moment the custom profile is very same as the default profile, but I want to show you some options that you can set in the profile. Okay, before that, how you can restrict the memory. So if I show you the memory, it's going to be the same for CPU. Okay, let me log into one of the machine. LXC exec my VM bash. Okay, I'm in here free minus M. So I'm seeing the complete 2 gig of memory that was on my host machine inside this container. So if I want this machine to use not more than 512 meg, half a gig of RAM, because if you don't set any limits, there are possibilities that any process inside your machine might be resource intensive, and it could end up using all your host memory, leaving your host system in danger. So it's always a good practice to limit the amount of memory, number of CPUs on your machine containers, so that it won't be able to use more than the amount that you specified. So it'll all be done using C groups. Okay, so free is, so now it has got 2 gig. Let's set it to half a gig. You can do it dynamically, or you can set it in the profile. So I'll show you both the ways. LXC config set and the container name my VM. The option is limits.memory 512 MB. Permission denied. Okay, let me log out and log back in. LXC list, LXC config set my VM. So I'm going to set the configuration for my VM, which is dynamic. The container is running. I haven't stopped the container, so whatever change I'm going to do is dynamic. LXC config set my VM limits.memory 512 MB. That's done. And if I do LXC config show my VM, wipe that to less, you can see the configuration is set here. Limits.memory is 512. Okay. So back inside the machine container, if I do free minus M now, you can see the memory that it can use is only half a gig. It can't go more than half a gig. And you can change it again to 1 gig, 1 GB. And if you do free minus M, and you can see the change taking effect. So that's dynamic. What if you want to set it as set it in a profile? Okay, let's delete that VM. LXC delete minus minus force my VM, and let's edit the custom profile that we just created. LXC profile edit, and the profile name is custom. Okay, so in the config section, just remove the curly braces and type in limits.memory 512 MB. Save it. That's the profile. Now if you try and create a virtual machine applying that profile, then you will get those details, configurations from the profile. LXC launch Ubuntu 16.04 my VM 2 minus minus profile custom, creating my VM2, and it's going to use the custom profile that we created, and the only change we made was to set a default memory limit of 512 meg, half a gig. Okay, LXC exec my VM2 bash. We are inside the container, host name. Okay, IP address is that one, free minus M. Now you can see it's half a gig of memory. So setting the CPU is going to be the same, and since I'm on my virtual machine, I forgot to set the number of CPUs, so my virtual machine has got just one CPU. If I had like 2 or more CPUs, I could set in the profile limits.cpu to 1, for example. LXC config set my VM2 limits.cpu to 1. If you've got like 2 CPUs and if you want to assign just one CPU to to the machine container, you can use that command. Okay, and okay, we've covered all these. Let's go to the snapshot, restore, and file operations. Okay, so if you want to push a file to the container, or if you want to pull a file from the container to your host machine, you can use the file command. Okay, LXC exec myvm2 bash. I don't have any files in there. Okay, on my host machine, I'm going to create a file, echo hello there, to a file called my file. And if I want to push this file into the container, into that machine, I'm going to use LXC file push, the file name to push, and the container name and the path inside the container. So the container name is going to be myvm2, and it's not semicolon or it's not colon. It has to be in this format. Container name slash and the path inside the container, whether it's etc blah 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 or root. Okay, and if I do ls, and you've got the file there, cat my file. Okay, so the file is in the container. I'm going to delete the file on my host machine. I don't have it here. Now let's pull the file from the container to the host machine. It's just the other way around. LXC file pull from my VM2 and the path my file to the local machine, cat my file. Okay, so that's how you use the file command. Okay, so let's quickly do the snapshot and restore capabilities. That's there, and let's snapshot the machine first. Okay. Okay, so I'm going to create some directories for I in dollar sequence 5 do make dir dollar I done. Okay, so I've created 5 directories named 1 2 3 4 5, and let's exit out of the container. I'm going to create a snapshot of this container. The command to do is LXC snapshot, the container name and the snapshot name, snap1 for example. So basically it's going to copy the entire file system. So as you saw earlier, it's the size of the image is 158 meg. So when I say it's going to snapshot it, it's going to copy the entire file system. Okay, so that's done. And if I log into the VM and delete all these directories, rm minus rf, I haven't got any directories. Say for example I accidentally deleted all these files. What I could do is I could do LXC restore my VM2 and the snapshot name. I think if you want to see what snapshots are available, if I do LXC list, and in the snapshots column you can see there is one snapshot for this container. LXC help snapshot, LXC snapshot, and the name create snapshots. I'm just seeing if there is a way to find out the name of the snapshots. LXC help restore snapshot. Okay, less restore containers from the snapshot. LXC help snapshot less. Okay, when you create a snapshot, you can also pass minus minus stateful. That saves the running state of the container as well. I don't think we've got an option to list the snapshots. I don't know. Okay, let's not worry about it. The command to restore a snapshot is LXC restore the container name and the snapshot name. So it's restoring the snapshot that we created earlier, LXC exec my VM2 bash, and you can see all those directories there. So basically we've restored the machine from the snapshot. Okay, cool. And what else I'm going to show you? Nested containers. Let's do a quick demo on nested containers. So we've got a virtual machine. Forget about the virtual machine. So it's a machine, and you have the LXD machine containers. So I'm going to log into one of the machine, LXC exec my VM2 bash. So I'm inside the LXD container. So inside this container, I'm going to create another LXD environment. So what we do, see if there is LXC and LXD packages installed, which LXD is there. Systemctl status LXD. It's not started, so let's start it. Systemctl start LXD. Systemctl status LXD. So that's running. The other thing to note is security.privileged and security.nesting. We haven't set those things up for the my VM2 machine container. So if you want to create a container inside a container inside a container, you need to set the security.nesting configuration as well as security.privileged. I'll show you what happens if you don't set those options. Okay, so the LXD is running. It's not a privileged container, it's an unprivileged machine container, my VM2, and it's going to show us some warning. I'm going to show you what it looks like. LXD init. Do you want to configure a new storage pool? Yes. Name of the store used, the default is directory. Okay, and that's the warning. We detected that you are running inside an unprivileged container. There might be some issues. Okay. Control C, Control D. Let's stop the container and set these options. Okay, so these are not dynamic like memory and limits.memory, limits.cpu. So we need to stop the container, make the configuration change, and then start the container again. LXC list, LXC stop my VM2. Okay, LXC config set my VM2 security dot privileged is true. LXC config set my VM2 security dot nesting to true. By the way, you can also do LXC profile edit custom and set these here. Security dot privileged is true. Security dot nesting is true. Save that. And for any, okay, there's some syntax error. Yep, I missed the colon bit. Control X. Okay, so that's done. And for any new containers you start, and if you use this custom profile, it will be a privileged container. Okay, so LXC list, let's start it. LXC start my VM2. See how quick it was. Just took less than a couple of seconds to start the container. LXC exec my VM2 bash. LXD init. Do you want to configure a new storage pool? Yes. Backend directory. A new network bridge? Yes. Yes. Would you like to set up a network bridge? Yes. The name of the interface. Everything is going to be default. Okay. 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 So that's all done. And if I do, I'm inside the machine container, and there is another bridge inside that container. And if I do LXC list, you can see that There you go. So that's my machine container. And apart from the ETH0, we've also got the network bridge, because basically this is an LXT host now. It can also host nested containers within it. LXC version, LXC. So that's the LXC version. On my Ubuntu 18.04 machine, if you noticed LXC version, it was 3.03. And on Ubuntu 16.04, the LXC version is 20.11. Okay, LXC remote list. Generating a client certificate, this may take a minute or so. Okay, so that's the difference, basic difference between 1604 and 1804. And you see all those remote list. LXC list, you don't have any machines. If you want, you can start LXC launch images colon CentOS 7 x86 underscore 64 or i386 or whatever you want. So basically that is the nested containers, container within container within container. Okay, I think that's all I wanted to show you. Okay, yep. LXC lists. Right, okay. Right. I think I haven't missed anything. Okay, cool. Thank you so much for your time watching this video. I hope you found it useful. Please share it with your friends, and if you haven't already subscribed to my channel, please subscribe to my channel. And if you don't understand anything, or if you're having problems, if you're having some issues following this tutorial, please leave me a comment. I should be able to help you. And if you're trying out this on a different distribution, I can help you out as well. Okay, let me exit out of the virtual machine. So that's my host machine, which is Manjaro, Arch Linux based. And if you want to install LXC in your Arch Linux, the command to do is sudo pacman -s LXC to install the LXC libraries. And to install LXD, you have to install LXD from the community repository, AUR, Arch User Repository. So yay minus, usually it will be yart. Previously I've got a package called yay, yet another yart, I think. Yeah, -s and LXD. So LXD is available from the community repository, LXC from the default pacman repository. Cool, and I'll see you in my next video. Thank you so much for watching this video. Bye bye.